Welcome to Morse's Math Morsels. In an earlier video, I gave an introduction to what a conjugate is, and this includes examples of the power of conjugates. And as in power, I don't mean exponents, but how useful and handy and efficient conjugates in mathematics can be. And a few examples follow. And a couple of explanatory notes. I is the imaginary unit, which is set equal to the square root of -1. And another note, I times negative I is +1. So there's an example of a positive quantity times a negative equaling a positive. So the number I itself, the square root of -1, has amazing properties and powers of its own. Anyhow, back to the conjugates. I'm going to do some multiplications involving some examples of quantities such as a plus bi, each of them being multiplied by their conjugates. Here we have a plus bi and a minus bi, and a is being added onto each. So for a plus bi times a minus bi, I'm going to do the minus bi times a, and that's just a negative abi. And negative bi times a positive bi, and because I times negative I is 1, the i's are going to come positive 1 there as well, and plus b times a minus b is going to end up being a plus b squared. Finally, we have a times bi, which is a plus abi. And finally, a times a, which is a squared. Well, if we add these terms, well, we have a negative abi and a positive abi, and they are going to cancel. One is an opposite additive inverse of the other, leaving just a squared plus b squared. One power of conjugates was the cancellation, the total disappearance of terms containing the imaginary unit I. And on to some arithmetic examples. 7 minus 2y times 7 plus 2y. Well, 7 times 2y is just 14i. Multiply 7 by 2 and then stick the I on the end. A negative 2y times a positive 2y is going to be a negative 4 times I squared. I squared is going to be -1. And negative 4 times -1 is 4. So this is going to be 14i plus 4. And further down, we have 7 times negative 2y, which is the negative 14i. And finally, 7 times 7, just 49. And add, and once again, note the cancellations of the I terms, 14i and negative 14i. Their sum is 0, leaving just 49 plus 4, or 53. 53 is a prime number, but only in the real numbers. Here I showed how 53 can be factored into two complex conjugates, a 7 minus 2y and a 7 plus 2y. Well, there's another example of the amazing world of the imaginary number I being used in a conjugate. You can't factor primes such as 53 after all. Just have to use the complex numbers to do it. I'll make room over here for the next example. 1 plus I times its conjugate, 1 minus I. And as before, it's the negative I times 1 is just negative I. Positive I times negative I, look at my note down here, is 1. Finally, 1 times I, that's a positive I. And 1 times 1 is very, very trivial, that's just a 1. And add 1 plus I. And once again, you'll notice negative I and a positive I drop out. We're left with 1 plus 1. Oh, so we're back to very elementary arithmetic. 1 plus 1 equals 2. So we factored 2 into complex conjugates, 1 plus I and 1 minus I. That product is merely 2. Once again, notice the I terms dropped out. Those negative I plus the positive I is 0. Last example, 3 minus 8i times 3 plus 8i. Alright, the 8i times the 3, that's going to be a 24i. Minus 8i times a positive 8i, that's going to be 64. I've got the negative I times a positive I, which is 1, and then 8 times 8 gives a positive 64. Finally, with 3 times a negative 8i, that's a minus 24i, and 3 times 3 is 9, and you guessed it, the 24i's are going to go away. Plus 24i and minus 24i, we're left with, and that's a plus there, 9 plus 64 equals 73. Once again, we factored 73, a prime number, into a conjugate pair, 3 minus 8i and 3 plus 8i. Now, those were examples of conjugates with the imaginary unit I. Thanks for viewing.